Hello and a warm welcome back. Today on the bench is the Tektronix 5858 replacement transformer bobbin, and as you can see I've got the first layer of windings on there. This is the first layer of the primary. In total there will be about 6 turns, but the original had a centre tap, although I'm not quite sure whether I shall still follow that protocol. So as you can see, they're quite neat. I'll zoom you in a bit. So yeah, I've got them, you know, there's no big gaps. There are a few gaps, but this is all winding by hand, so, and even with an automated winding machine you're probably still going to get gaps. This is 1mm wire. It works out at 1.08mm once you add the enamel on. So what I've been doing, I'll just zoom you back out again. So what I did, I put about 10 turns on, and then I dressed it using wooden tools to try and shove the windings together, to dress them properly and to get them to be as flat as possible. Just use a bit of wood and clunked them with a hammer gently. I did some calculations to try and figure out how much of the winding window, which I've mentioned once or twice, that my proposed windings would take up. And ideally I should have got 67 turns across here, but in actual fact I got 64, so that's not bad. I don't know what the original is. For the last 3 days or more I've been really prevaricating and dithering about whether to add some insulation onto the top of each winding. I've got various insulating materials. I've got this yellow tape. I've got it in the full width. I've got this sort of brown paper with a sticky sort of surface, which I've used on previous toroid transformers, and I've got this hook of stuff which is Nomex. This paper obviously can be torn quite easily. This, I was going to say can't be, but basically that is just, the brown stuff is just paper fibres, wood fibres. This should have some cotton in it. Yeah, okay, I can tear it that way but can't tear it that way. However, the problem is that if I add a layer of insulation on top of every layer, then that will take up window space. And is it necessary? According to my calculations, each turn should be about 0.65 volts. So where are we? That's about 40 volts from here to here of each layer. So between each winding is what, about less than a volt, but from here to here is 40 volts. So if I put another layer on top without any insulation, we've potentially got 40 volts potentially shorting out to the layer on top. I'm sure that the insulation on this wire can cope with that. I've not actually been able to find any voltage figures for enamelled wire, only heat sort of ratings. The other thing that insulation does, apart from insulating, is to create a stable surface for the next layer to go on. If you just look at this rough drawing here, this is our first layer. And obviously when you wind a transformer, the wire wants to go in the divots, so there's like a divot there, divot there, divot there, and so the the winding on top wants to sit like that. So if we've got, say, if we've got 10 turns across here, then obviously if the wire wants to sit like that, we're going to get less turns across the one on top. And then if we also put like another one on top of that, then you got this gap, and you can see like there's some potential conflict there. If we use an sound like Donald Trump. If we've got an insulation layer between each one, theoretically the winding on top should just be able to sit there quite happily, and therefore we should get more turns. However, every time we bung a bit of insulation between the windings, which I don't think is absolutely necessary from a electrical insulation point of view, then we are obviously losing some thickness. We're losing some of our window. Potentially, if I was to add some of that Nomex in between every layer, then that would take up about 2 mil. But in reality, I know it will take more, just from experience. Originally, I thought that what they'd done in what Tektronix had done when they wound this was to put some like filler material in there, i.e. something like this stuff, which is a body filler, which is, we used to call plastic padding in the old days. It's just an epoxy sort of resin filler stuff. But having looked at it in more detail, I don't think that is the case. I think what this is, obviously having been crushed like for God knows how many decades, is a layer of insulation. I measured the insulation off the old transformer, and it's about 5 thou thick. No, it's less than that. I think it's about 2 thou thick. Anyway, I've decided not to bother with insulation in between these windings. My calculations tell me that, what did they tell me? I worked out my window, that is the primary and most of the HT windings, and I worked that out to be about 38% of our winding window, which is good. And then unfortunately it doesn't really end there. We've got all these heater windings, which, as you can see, they are really numerous. In fact, there's more heater windings than there are HT windings, high voltage windings. So what I'm thinking is, I'm just going to crack on with it. I mean, there's nothing I can do. I can't reduce the wire diameter. There's not much I can do about the increasing the core or increasing the bobbin size. So I'm just going to have to live with what I've got. But however, if I do run out of space, what I thought about doing, and I have thought about this in the past when we've had this problem with these transformers, is to use another transformer for, say, the heater windings. For something like that, I need a 300 VA core, and it just so happens that I've got a spare 300 V8 toroid core. However, that means like loads of bloody windings to, wind a primary, etc. It's less than ideal. The other sort of part of the windings which is a difficulty is one of the heater windings has got to be insulated to 1350 volts. That's because it supplies the cathode ray tube. And then there are these two, the 140 volt winding and the 217 volt windings. They're the ones that have screwed up in the past. The insulation breakdown has basically killed all the transformers. So it killed it killed the previous one on the 585, so it's killed 2 mains transformers, hence me rewinding this one. And it's also killed a 545B transformer. So what I'm going to do, I won't follow exactly the layout that Tektronix used. I will separate them more than they were on the original. Hopefully that will cure the fault. Right, so onwards and upwards. I'm going to bang some more turns on this transformer. Right, we'll try that. Take my brake off. As you get into the thing, into the rhythm, it's not too bad. But obviously if I've got, I mean this is only not many turns, but I've got a winding with a lot of turns on thinner gauge wire. It's going to take a fucking long time. Yeah, and I've got a bit of a screw up there. I don't know what went off there. Woo! So as you can see, I'm sort of straight there, and here I'm going like at a slant, and I think that is because I started off a bit wonky. I don't know what went off there. So yeah, all these little wrinkles and whatnot is what you get. I'll keep cracking on. I think that's enough footage of me going round and round and round. Catch you later. Here we are the next day. It's a bloody slow process, this is. Hopefully we'll speed up a bit later, because I'm getting my practical winding process sorted out. And I'm trying to take my time, because the last transformer that I wound was a screw up. So now I've got 2 layers of the primary on. In total I've got 132 turns. I've got 132 turns on, and I'm ecstatic about that, because I think if I remember right, we've got 64 turns on the first layer. So basically we've got an average of 66 turns per layer. Our measurements on when we did our window calculations were 67, so I'm really ecstatic about that. We're sound as a pound and fluctuating rapidly. This is good. The other thing I did was to measure the depth from here to here. That is good. That is where we should be. It's a little bit under, which is even bleeding better. Whoops. Which is even better. As you can see, I totally dispensed with the Nomex. It was just a pain in the arse and not needed, so I just basically put a bit of tape there to secure the ends, and then use some of the wider tape to, you know, insulate that. I'm happy with that. Everything's good. Now we have some decisions to make. We've got 132 turns on. The specification for the transformer calls for 172 turns. However, it's a little bit more complicated than that, and so I'll move you over to the drawing tablet. On the original transformer, what you got as regards to primary, you've got one big primary which is 172 turns. That's for 110 volts, and then you've got another one, and then what you've got to try to cater for mains voltages of other countries is these 2 buck boost windings. So depending how you connect them, you can cater for all sorts of voltages. Buck boost means if you connect them in series, then you get like you can use more mains, it can accept more mains voltage. If you buck them, you subtract. You're going to have to look into that yourself, buck boost, because it's this video is already long enough. For the UK mains voltage of it's supposed to be 230 volts, but our mains voltage here is 245. That's the RMS value. It can go up to 250. It's all over the bleeding shop. So for a UK mains voltage of 250 volts, you've got all these windings connected in series. So my thinking was, right, well, why bother with these bleeding buck boost windings which go on last on the actual transformer? Because I'm just going to zoom you back to the what they call it. Because we've got about 65 turns across here, then what, 40 turns is going to come up to about here, isn't it? So why not just put the buck boost windings to make space, you know, to make use of that gap on there? And that's what I shall do. However, there's a trap. The fan in Tektronix 500 series oscilloscopes is 110 volts, and so what it does, it sits across the primary of the mains transformer. So what it's basically doing, it's using the mains transformer as an auto transformer. If I was to do something like, say, 182 turns, making use of that space, then that would mean that the fan would see more than its 110 volts that it needs. So this isn't wired correctly. I'm just doing this so you can understand it. So what happens is that you get one half of your AC mains here, and remember, these aren't labelled as it is on the transformer. This is just for ease of your understanding. So you get one part of your AC there, say your live, and then you get your neutral here on this winding. You get your neutral here on this, connected to this winding, and then your fan is connected across just one of the main primary windings. Hope that makes sense. So if we've got, let's say, 250 volts, where are we? So it'll be 140 volts. So 140 volts will be dropped across these windings here, and 110 volts across that one there. Hope that makes sense. So what I've got to do is bring a tap out when I've got to 172 turns, and then I can wind all the rest of my windings on of the primary as I mentioned, without putting the buck boost windings on at the end. This scope will only be used in the UK. It ain't going nowhere. It ain't going to be shipped abroad to Europe or anywhere, as I can see it. That's a load more turns on. Where were we? 32, 8, 7, 50, 8 and 7 is 15, isn't it? The starting off is always a little bit precarious. Takes a little bit of bashing and whatnot. They're not lying too badly. What I'm going to have to do is move the camera away a bit, because I'm going to give them a bit of a bashing, and the microphone don't like it. The software, the editing software, don't like it either. I've got a pair of more grips stopping it from turning. All this won't be necessary for some of the other windings, this apart from the heater windings. Right, now we need to go back a bit, and this is where, if you're not careful, all your work gets screwed up. Yeah, I think you can see that. just going to put a bit of temporary tape on there and go back a bit. Every time I stop, what's going off? Every time I stop, it knackers how the wire lays down. As you can see, it puts kinks into the wiring. Winding this primary by hand is physically demanding. I've got a bad back, bad legs and all that, you know, from a motorbike crash, so I have to keep stopping, which is a bugger, but I'm getting faster. Anyway, let me move you. There we go, and don't look too bad, do they? If I don't say so myself. Just need to give them a... Actually, they have gone on pretty good. 172 turns on of the primary. I need to bring out this tap for the fan, as I mentioned earlier. Right, my plans have evolved a little. I've bared this winding here, sort of about here, done the end one here, and then what I'll do, I'll just solder that. But before I do that, I'll insulate it with some Nomex and secure the ends with some of this yellow tape. Right, the ends are secured there. Got a really hot iron. And now I'm going to use my meter just to check I've got continuity. There we go, that's good. Just do a quick resistance test. Yeah, that's good. So now I just need to cut that there and then put some insulation on. I also need to start addressing another potential problem. We've got loads of windings, loads of terminations. On the original Tektronix transformer, they were colour coded sleeving. I haven't got loads of colour coded sleeving. I've got a few different colours, but nowhere near enough. So to try and address that, what I've done, our friend Ian kindly sent me loads of this sort of heat shrink here. What I shall do is use some of it. So we've got number 1 marked. I shall try and use Tek's labelling system as far as possible. And then what I'm going to do there is right tap on that, pop that on there. Shrink that down, and then to make absolutely 100% sure that the boogers don't slip off, because this is what can happen, I'll just put some nail varnish on there, and hopefully that will secure it. It would have been better if I had some white or some clear adhesive heat shrink, but we've got to work with what we've got. Using a magnet, I've wound the counter on to 8700, so we've got a round number, and I'm also keeping copious notes. I shall write that down now. Start of turn 8700. It's really easy to lose your way if you're not careful. Start, oh fucking handwriting, of winding 8700, and then now I need to calculate how many more turns I need, and then I will add that so that I've got a stop figure. These are some of my notes for the winding of this transformer. So I've got a notepad here. I've got like stuff written on this bit of paper here, which I spilt a load of coffee on. I've got another bit of paper here with a load of bloody notes on. I've got that, and I've got some more notes here. Oh, and a load more notes here. So as you can see, I do keep notes, copious notes, but they ain't organised in one place. So what happens is, I come to the end of a project, be it a valve amplifier build or whatever, and I have all these sort of disparate notes, and I'm trying to think, well, what the fuck does that mean? I've got bits of paper everywhere over different notepads. It's not good enough. I would recommend, if you can, to take proper notes. Right, that's the primary finished. That's the primary done. Got a little bit of more tape to put on there. Next, the screen goes on, and all the HT windings and all the rest of it. So anyway, onwards and upwards. Thank you all for watching. Ta-da for now.